Hello everyone, we're looking at thermocouples. We're looking at the rosemount transmitter 3144P. We're going to calibrate it as a type K thermocouple. So here's what we're going to need. We're going to need a thermocouple. We're going to need a thermocouple wire with the adapter to go into our meter. We're going to be using a Fluke 726 precision calibrator. That's going to be our loop power. That's also going to be our ammeter, and that's also going to be our thermocouple input. We're also going to be using a heart communicator to be able to communicate with the transmitter. We're also going to be using some wire and some tools. So first of all, we're going to open up our transmitter. Now, I already have set out the two wires for the positive and negative. We're going to connect our meter wires, leads. We're going to turn our meter on, and we're going to connect our meter now. We have our positive going to the positive on the meter, and our negative of the meter going to the negative of the transmitter. Now, we will notice that we have our ground, positive, negative, terminals 1, 2, 3, 4, 5. How do we know where to connect up to? We can look on the bottom of the rosemount cap, and we see that it gives us the wiring for a 2-wire RTD, 3-wire RTD, 4-wire RTD, thermocouple. Notice the polarity. A temperature differential, that's the delta T, of 2 3-wire RTDs, or a delta T of the thermocouples. So 2 thermocouples, and it'll give you the temperature difference. Now, the other thing we're going to do is we're going to set up our meter. We're going to make sure, and as always, just read along. We're going to measure, but we're going to supply loop power. We're dealing in milliamp. Now this is actually heart capable as well. We're not going to use the heart function on there at the moment because we have a 475. The 475 is very powerful. It's touch screen. It's very easy to use. So we start up our heart communicator and we put our heart leads on our transmitter. Notice that there is the little tabs to put the leads on, and they go in parallel with our positive and negative. The polarity does not matter. Now, when we come back to our heart communicator, it's always going to give us errors if we're just starting to set it up, and it says there's a communication error. So we're going to exit. Sorry for the glare here. Let's see if we can. There we go. We're going to use heart communication. Now, sometimes you notice I'll be pressing enter, forward, or I'll be using one of the keys to drill down into a menu. Oftentimes you'll be using all three interchangeably. So we're going to go online. And sometimes I do all three until it just starts going. Okay, here we go. So we are going to, first of all, configure it because I know it's not in the proper configuration at the moment. So we're going to configure. You see the little heart going. That means that it's thinking. At least I hope it's thinking. There we go. And we're going to go to a guided setup. And we keep getting error codes because we are not set up correctly. And we're going to configure our sensor. Now, we're going to configure sensor 1. We're not looking at a delta T, so we don't care about a delta T. We don't care about sensor 2. So we are going to go and we're going to find a type K thermocouple. So TC thermocouple type K, enter. Now, if we go into the advanced features, it's going to ask us what do we want. Degrees C, degrees F, that's Celsius, Fahrenheit, and then we have degrees Rankine, and then we have Kelvin, which is not in degrees. Kelvin does not have degree unit. We are going to go degrees C. We can set sensor dampening on the temperature, because oftentimes we don't want to see temperature fluctuation. We want to see temperature over time. But here we're going to leave it at 0 so that we see the temperature movement. Okay, now we're going to exit. We're going to go to key 6, and it's going to go automatic. And we're going to go to the overview. Now, it says that we are out of range, and obviously we don't have a thermocouple hooked up yet. So what we're going to do is we're going to put our thermocouple into it. Now when we look, we have 2 is our positive. Let's go right down in there. 2 is our positive, 3 is our negative. Thermocouples, as per the US guide, Canada, US, red is always negative. So number 2 will be our positive. And this might get a little tricky here. I'm just using one hand. And three is our positive. Now, you'll notice that our milliamp dropped down to 7. We come over to our heart communicator and we have 7.396 milliamps, 7.4, and we have 7.4. You can also see that we have 21.2 degrees Celsius. Now, if I put my hand on the sensor, I just put my hand on the sensor, you're going to notice that that temperature is going to start to rise. Now we got another error. Now we're at 24. We're going to increase our temperature all the way up to about 27, 28. And my body temperature would go far beyond that, but we're not going to wait for that to go up that high. So here we have 27 degrees Celsius. And we can see that's just my hand on the thermocouple. So we can see that the transmitter is functioning. We can see that the temperature corresponds to our milliamp, as our range is 0 to 100 degrees C, and our output is 4 to 20 milliamps. And whatever we see here on our milliamp output, we should see here on our milliamp output. With all transmitters, there's 3 parts. There is your sensor, your electronics, and your D to A converter. Our sensor is a thermocouple. Our electronics is what the heart is communicating to, and our D to A converter, here we see the electronics are telling the D to A converter to put out 8.12 milliamps. And here we're putting out a little less now because our temperature is coming down, but it was putting out 8.12 milliamps. So we can see that our D to A converter is good because our, oops, let's exit that. It's a touch screen, don't forget. We can see that the electronics are trying to drive 7.9 milliamps, and we actually are getting 7.9 milliamps. So we can see that the D to A is doing its job. Now, how do we calibrate this? Well, we already have this hooked up. We could put this in a temperature bath. We could put 0 degrees Celsius by using an ice bath and then using boiling point of water, which would be 100 degrees Celsius. However, we could also use our our fluke to inject the signal, and then we can do it in 25% steps, and we don't have to carry an ice bath, and we don't have to carry boiling water. So if we remove our thermocouple, and we're going to insert our connector into our fluke. Now again, we have to set up our meter. So we're going to source. We're going to go thermocouple, and it's already on type K. So now we have to look at our wires, and you can just see them if I can get a clear view of it here. There you go. The red is on the left, which is our negative. Our negative is number 3, terminal 3, and our positive is terminal 2. So now, if we split these wires a little bit further, we could put them like that. This would be a lot easier if you're using 2 hands rather than 1. Okay, so now we're actually sourcing with our fluke meter, using our fluke as the standard for not only the input, but for the output, because we are using it to input our thermocouple input, which is millivolts, and we are seeing what the transmitter is outputting with the milliamps. Okay, so now we can see that we want 0 degrees Celsius, and it should be giving us 4 milliamps out, because that's our 0. So if we look at our fluke and our heart communicator side by side, we should have a reading of 0 degrees, because we're telling it we are injecting 0 degrees, and the transmitter says I'm reading 0 degrees. I'm going to output 4 milliamps. And it is outputting 4 milliamps. So now I can simply, let's see where our 25% steps are. Wow, that is a hefty 25% step. Let's put that up to 0. Okay. We're not going to set that meter up right now, but we will just put it up to 20. And here we should get 20 degrees C, which is giving us 7.2 milliamps. If we wanted 8 milliamps, we would go to 25 degrees C. And you see, now we're at 25 degrees, very close. And it will get closer. And now we have very close to 8 milliamps. And we keep getting an error here because this transmitter is having a little bit of issues. It is not a brand new transmitter, and the electronics do need to be replaced on it. So that's why we keep getting the error message. So now if I go up to 50%, so we'll be looking for 12 milliamps and 50 degrees C. So here we're inputting 50 degrees C. Our electronics are reading 49.92 degrees C. Our electronics are telling our D to A to drive 11.98 milliamps, and we are seeing 11.99 milliamps. So that is extremely close. But now we're going to go up to 100% of our range, which is 100 degrees Celsius. We want 100 degrees. We're inputting 100 degrees. We are reading 99.8 degrees C. Our analog output is what it wants to drive is 19.99 milliamps. And we are, in fact, driving 19.99 milliamps. So this transmitter is very much in calibration. If we needed to, we could always go into our service tools, and we could do maintenance, and we could calibrate the sensor, or we could calibrate the analog output. But for this, we're wanting to show the hookup and the calibration of thermocouple for the rosemount 3144P. This is the simplest and easy way to do it, and it makes life really easy, especially if you have to go out into the field where you don't have a whole bunch of test equipment. All you need is these two instruments, and you can see everything that's going on inside that rosemount. I hope this video helps everybody understand how this thermocouple transmitter is so effective and so easy to use, and especially with the heart communicator to maneuver around inside the menus. It's extremely easy. And the really nice thing is when we go to our overview and we actually see what the degrees C are that it's reading and what it's trying to output, and it tells us our ranges, so we don't have to guess. Okay, but we should also have a data card that tells us if wherever you're working, you should always have a data card that says this is what the transmitter should be set up to, so that everybody's doing it the same. So that's for thermocouples. The next video that we'll do will be on RTD for the rosemount 3144P.